Hello everyone, my name is Jacob and today I'm going to show you how to create some block memory and initialize it in Vivado just for your FPGA design there. So I've gone ahead and created a new project here where I'm going to be showing you guys how to do all of that. I think the first step though, easiest, is to write a Python script to create your block memory. So I've gone ahead and kind of outlined a Python script right here for you. So the first step, we're going to go ahead and create a file or something. I'm naming a file and I'm just opening it. Let's call it, good name is just like a work file or something like that. I'm going to do .txt here. And then let's go ahead and set it to write mode. So we're going to be writing to that file. And then let's go ahead and also do a linspace here. If you prefer to use something else to create your numbers, go ahead. But we just need 10,000 data points between 0 and 1. Let's go ahead and then use those to generate a sine wave. So we've got p.sine, and we're going to go from, well, just multiply by 2 pi. And so there we've got our sine wave. Now we kind of need to normalize that and adjust it for our bounds. So let's create a new one called f, and that's going to be half of that. So instead of going from 0 to 1, or excuse me, from -1 to +1, we're going to go from -1/2 to 1/2 of x, and then let's go ahead and add on a half as well, just to make that go from 0 to 1. And then let's also just do multiply the whole thing by 4095. That'll give us our full 12 bits worth of information there, just from 0 to 4095, which is FFF hexadecimal. And then we're going to go ahead and create a for loop. Just to count through all of those, we're going to start at 0 and then go to the length of f here. And just for all of that, it's pretty simple. We're just going to write after that. I'm going to put it in hexadecimal as well. So we're going to cast it to a string and then an int, just because it was a float, and then just go ahead and close all of those parentheses except the last one, and then we're also going to add a comma at the end of everything and then add a new line. So for each one of these, it's going to output the string in hexadecimal and then a comma, and then move to the next line. And so that's pretty much everything there is there. Go ahead and save that file, and then open up whatever you use to run Python scripts, and just pull that up here. So I usually do mine in Ubuntu here, just a subshell here. So we're going to do Python and then the name of the file here, and click enter. And that has run. Let's go ahead and open up a file browser. And if you see right here, I've got a file called workfile.txt. So let's edit that with Notepad++. Don't want to use regular Notepad. And I'll show you in a moment why. But if you look here, you've got your 10,000 valid data points. So we're going to do a couple of things. The first one, let's change the last comma to a semicolon right there. Don't miss that. And then scroll back up to the top. And before everything, we're going to add a couple of lines. So I'm going to do memory initialization. And then radix equals 16. And then we're going to do memory initialization vector. And then we're not going to go ahead. we're not going to close that here because that's closed at the end of this list. So right here, we've pretty much got everything. The first line, the radix, says that we're in hexadecimal, and then these are all of our values. And let's just do next thing. The last thing we have to do with this file is just delete the OX off of that. So the easiest way, just do a find and replace. Type in OX in the find, replace with nothing, and just click replace all. And that's a 0x, not an LX. No, but just click replace all and let it run for a moment, and eventually you've got your whole file here. So we're going to go ahead and save, click save as, stick that in our project folder. Good place is in sources, just right here is a good place, and we're going to name it ip.coe, and good. I guess I did ip.coe.text, so we're going to go ahead and just navigate there and there we go. We've got our configuration file. So next we're going to move back to Vivado here and just go to IP catalog and type in memory and scroll down until you see a block memory generator. So click axis 4. We want this to be single port RAM. If you deselect this byte write enable, that makes it so you can only read to it. You can't write. We don't need to read or write to it, so I'm leaving mine deselected. Let's go ahead and change our write width to 12, just so, and the read width, and that just makes it so you've got 12 bits wide, and we need our depth to be 100,000, and it should auto-populate into the read depth. So that's everything in the port A options, and then let's go ahead and move to other options. There's a load init file right here, and browse for your COE. It may come up right there, it may not, but just go ahead and find it. And there we go. I've got that loaded, and click OK. It's going to ask you if you want to create the IP directory, and just click OK. And go ahead and wait for that to load, and you should get everything. You can go ahead and change this to global if you'd like. I believe it should synthesize faster if you leave it as out of context for IP though, so I'm just going to do that and click generate. And then we'll just wait for a moment here while it's loading. And then let's see what's going on there. So yeah, it's loading for a moment. And then the next thing, pretty much after that, everything should be okay. The only thing we've really got left to do is add it to our module. So if you go ahead and come into your sources, you can click this little arrow, and it's going to give you a pop-up here. Click OK. And then wait for it to load some more, like always pretty much. And that should load now. There we go. And if you see here, there's another source you can take a look at. And if you look just right here, there's an entity, and that's exactly what you want to copy. So just steal that entity right here and come back to your top module level. I've kind of got the shell of mine, mule code, but just on there, and then just change that to a component here. Alright, and then you can go ahead and come down here to where you'd instantiate it and just add in yours. I've already got kind of an example written up here, so go ahead and just paste that in. And there we go. I've gone ahead and added in my block RAM and put it in there. It's giving me some kind of issue right now. Oh, that's why. I must not have. Oh, I did not leave an enable. So if you do have an enable still there, just go ahead and do an A. And in my case, I'm just going to tie it to 1 because I always want it to be enabled. But you can go ahead and do whatever you'd like to connect yours to. But anyway, that's pretty much it. You've got your block memory in here, and then just go ahead and tie everything in. One thing that is kind of interesting to note is the address is a standard logic vector, and so if you want to use like an integer, I've got address here is declared as an integer. If you look right here, it's an integer. So if you come here, it's going to be 17 bits big, so we're going to just convert that integer into an unsigned of 17 bits, and then we're going to convert that into a standard logic vector and attach that to EDDR and just stick that right into here just so we can communicate. And then just go ahead and use your address like normal. And then I just kind of made a clock process because I thought that would be easiest to go ahead and step through everything else, but you're welcome to do however you'd like. Anyway, that's how you implement the block memory in Vivado.